Hi, today we're looking at GCSE Maths. We've got the Pearson Edexcel exam board. This is from the May-June 2022 period, and we're looking at paper 1, so this is the non-calculator paper. Question 1. Change 40 centimetres into millimetres. Okay, well, I know that 1 centimetre equals 10 millimetres. Okay, 40 centimetres into millimetres, so we're going to have more millimetres than centimetres because they're smaller. There's 10 in each, so it's going to be 40 times 10. When we multiply by 10, we just add a 0 on the end. So we're going to get 400 millimetres. Question 2. Simplify E plus E plus E plus E. So we've got 1, 2, 3, 4 E's. Simple as that. When we've got a number written next to a letter, it means times. So 4 times E or 4 E's. Question 3. On the grid, reflect the shaded triangle in the mirror line. Okay, so we want to reflect it. Best way to do is to start from the corner point here. And that's 1, 2, 3 boxes in. So if we go 1, 2, 3 this way. And then we can use our ruler to connect this corner up to here. Do the same on this side. There we go. Got a reflection. Question 4. Write down the value of the 6 in the number. Well, I'm first going to put in 1, 2, 3, put my comma in here, so it's easy to read. So the value of the 6 in the number 16,007. Well, the 7 would be the units. This would be the tens, hundreds. The 6 is the thousands. So the value of the 6 is going to be 6,000. Question 5. Write these numbers in order of size. Start with the smallest number. So we've got 1 as a fraction, 1 as a decimal, 1 as a percentage. So it's going to be easy to make them all the same, I think. So I'm going to do them all as percentages because I know a half is 50% and 0.55. Well, if I want to make it a percentage, I multiply it by 100, which means moving the decimal point twice. So that's going to be 55%. So we've now got, we want smallest number first. So 45%, 50%, 55%. So 45% first, 50%, although it's given as a half, so I'll write it like that. And then instead of the 55%, we'll write it in the way it was given as well, which is at 0.55. Okay, question 6. The pictogram gives information about the number of hours of sunshine on a Saturday and on a Sunday. We've got our pictogram here, and we've got the key that says each sun represents 2 hours of sunshine. Work out the number of hours of sunshine on Saturday. So Saturday is here. So each sun is 2 hours. So we've got 2 hours, another 2 hours, another 2 hours, another 2 hours. So 2, 4, 6, 8. That's our answer. Question 7. Simon buys some candles. Each candle costs £2. Simon pays with a £20 note. He gets £6 change. Work out the number of candles Simon buys. Right, okay, well, let's work out how much money he spent, first of all. So he paid with a £20 note and got £6 change. So we want 20 minus 6. We could just count back from 20, really. Let's do it that way. So start with 20, and then 19, 18, 17, 16, 15, 14. Okay, so £14 was spent on the candles. Each candle costs £2. So we want 14 divided by 2. So 2, 4, 6, 8, 10, 12, 14. That's 7 times. So that's going to be 7 candles. Question 8. The bar chart shows information about the total rainfall each month for 4 months in a city. Yes, we've got it there. Total rainfall going up the side. We've got our months: January, February, March, April, May and June. And we're told in May the total rainfall was 35 centimetres. In June the total rainfall was 20 centimetres. Use this information to complete the bar chart. Okay, so this should be reasonably straightforward. So May, we've got 35 centimetres, so here's May. So we go up to 35, which is going to be here. Use my ruler. And I'm doing the bar the same width as the other bars. Draw the vertical lines down as well. Okay. And then for June, the total rainfall was 20 centimetres. So we want to go up, and 20's here, so this is where we want it. That's the first part. Then Rupert says, in February there was 15.5 centimetres of rainfall because the bar is half a square above 15. Explain why Rupert is incorrect. So let's have a look at February. Here's February. Well, here's 15, but here's 20. So this difference is going to be the difference between 20 and 15. Or if we count up from 15, we've got 16, 17, 18, 19, 20. So this is actually a height of 5. What she's saying is because it's half a square, she's counting it as just half a centimetre. But in fact, it should be half of 5. So, explain why Rupert is incorrect. And we can say, because each square represents 5 centimetres, or centimetres, not 1 centimetre. Something along those lines. We could go into more detail and we could say the actual measurements. If we wanted to, we could say, well, this is going to be halfway between 15 and 20 and work out the value. But because it's only 1 mark, just a few words like this should be enough. Question 9. Here is a sequence of patterns made from grey square tiles. Pattern 1, pattern 2, pattern 3, pattern 4. You can see it's getting bigger each time. On the grid below, draw pattern number 5. Okay, well, let's see what's going on. Well, pattern number 1 is 1 high and 1 across. Pattern 2 is 2 high and 2 across. So I think for pattern 5, we're going to want it to be 5 squares high. So 1, 2, 3, 4, 5 up to here. And 5 across. 1, 2, 3, 4, 5. And it's just 1 square wide. Okay, there we go. If you want, you could do some shading just to make it clear. And then for part B, complete the table. So pattern number 1, and it's got how many squares are used up. Well, for pattern number 5, we can just count because we've just done it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll put that on. Now pattern number 6. Well, pattern number 6, and if we compare it to the others, it's going to be the same, but it's going to go an extra square down here and an extra square out here. So it's basically what we had before, which was our 9, 10, 11. And we can see that if we look at these, we can see they're going up by 2 each time. Question 10. In Norway last year, the lowest temperature was minus 15 degrees. In Norway last year, the highest temperature was 42 degrees greater than the lowest temperature. Work out the highest temperature in Norway last year. Okay, so you can think of this as if we've got a thermometer, but we're doing it horizontally. So the lowest temperature was minus 15 degrees. We'll have this as 0 here. The highest temperature is 42 degrees greater, so we want to go up 42 degrees. Well, first of all, let's see how many degrees do we use up just going from minus 15 to 0. Well, that's going to be 15. That's going to be 15 degrees there. So this bit up to, we don't know, is going to be the difference. So it's going to be the 42 minus 15. So we can do 2 subtract 5 or take away 5. Can't do that because 5 is bigger than 2. So we need to take 1 from the 4, reduce that to a 3. Give the 1 across. So now we've got 12 minus 5. If we count back from 12, we'd have 11, 10, 9, 8, 7. 3 minus 1 is 2. So the maximum temperature is going to be, or the highest temperature was 27 degrees. Question 11, and this is worth, somewhere down there, 4 marks. Let's bring it back down. At the end of October, Fiona's electricity meter reads 88,738 kilowatt hours. Don't worry if you don't know what this stands for. It's just some unit. At the end of November, her electricity meter reads 89,198 kilowatt hours. Each kilowatt hour, or kWh, of electricity Fiona uses costs 16p. Work out how much Fiona had to pay for the electricity she used in November. Right, so first of all we need to find out how much, we want to know how much she had to pay, so we want to know how many units she used first of all. So let's start with the new amount, the 89,198, and subtract the starting amount. This will tell us how many units she used up. Well, 8 minus 8 is 0. 9 minus 3, count back 3 from 9, we'll have 8, 7, 6. 1, take away 7, we can't take 7 away from 1. So reduce the 9 by 1, and we can make that 11. 11 minus 7 is 4. 8 minus 8 is 0. 8 minus 8 is 0. So we've got 460 kWh we used. Now each of these costs 16p. So we're going to multiply this by 16. 6 times 0 is 0. 6 times 6, we've got 6, 12, 18, 24, 30, 36. 4 times 6, 6, 12, 18, 24, plus 3, 25, 26, 27. Now we move on to the tens, so we can put a 0 down here. 1 times 0 is 0. 1 times 6 is 6. And 1 times 4 is 4. So we add these together. 0 plus 0 is 0. 6 plus 0 is 6. 7 plus 6 is 13. 3 carry the 1. 2 plus 4 is 6. Plus 1 is 7. So 7,360, and that is p, that's pence. Now, they haven't actually said how to write this, so we could just write it as 7,360p, or you could do it in pounds and pence. So if we want it in pounds, we're going to have to bring the decimal point in twice. So we could write it as £73.60. So it should be fine as 7,360p. What you don't want is £73.60 and put the p at the end. We either have it with the p in the thousands or just with the pounds and the decimal point. Question 12. Part A. Work out 5/12 plus 1/6. If we want to add fractions, we need the denominators to be the same. They're not here, so we say, well, does one denominator go into the other? Well, yeah, 6 divides into 12 twice exactly. So that means we can keep the 5/12, the one with the bigger denominator, the same. And we want to rewrite this fraction with that bigger denominator. And we've already said, well, 6 or 2 6s are 12, so we're multiplying it by 2. So we're going to, whatever we do with the denominator, we need to do with the numerator. So 1 times 2 is 2. Now we've got both the denominators are the same, so we just keep that for our answer, and we add the numerators. So 5 plus 2 is 7. Part B. Work out 3/10 times 5/8. Give your answer as a fraction in its simplest form. Okay, so 2 ways to do this. I'm going to do this maybe the more straightforward way, but slightly longer way first. So when we're multiplying fractions, we just multiply the top together and multiply the bottom together. So 3 times 5, 5, 10, 15. And 10 times 8, just put the 0 on the end, we get 80. Then we've got to say we want it in its simplest form, so any common factors. Well, I know that any number ending in a 5 means that it's divisible by 5. And if it ends in a 0, it's divisible by 10, which means it's also divisible by 5. So let's divide both by 5. Well, we know 3 5s made 15, so dividing by 5 will go back to 3. 80 divided by 5, well, let's do it with the bus stop method. 5 into 8 goes once, remainder 3, and 5 into 30, 5, 10, 15, 20, 25, 30, that's 6 times. So we get 3 over 16, or 3/16. Now, an alternative way is to say, well, let's try and simplify this before we do the multiplication. And what looks nice, I can see, we're looking for a number in the numerator and one in the denominator that look like they will cancel or simplify nicely. And 5 is half of 10. So I'm just going to change the order of these. So I've just swapped them around because we're multiplying the tops and the bottoms. So I've just put the 5 first and the 3. So we've got 5/10 times 3/8. Still the same thing, but what that means is we've got 5/10 now, and we said earlier 5/10 is a half, so we can write that as 1/2 times 3/8. So then we just have to say 1 times 3 is 3, 2 times 8 is 16. So 2 ways of doing it. Both of us give us the same answer, 3/16. It's nice if you can start to do things this way. So it makes the working out a little bit easier, but you do need to be able to see what's the best way to rearrange the fractions so they can simplify down better. Question 13. There are 15 sweets in a jar. 4 of the sweets are red. Jill takes at random a sweet from the jar. Write down the probability that the sweet is red. Well, there's 15 in the jar, so that'd be our denominator. 4 of them are red. It's going to be 4 out of 15, or 4/15. And there are only green counters and blue counters in a bag. So we've got a bag now. We can forget about the jar. A counter is taken at random from the bag. The probability that the counter is green is 0.3. Find the probability that the counter is blue. Well, all probabilities add up to 1. So if the probability that it's green is 0.3, well, the probability that it's blue must be 1 minus 0.7. And it might be easier to think of this. Well, we can do this as a subtraction. So we want 1 minus 0.7, but I'm going to write it as 1.0 minus 0.7. And the way we'd do that, we'd say, well, I can't take 7 away from 0. Let's reduce that to 0 and make that a 10. 10 minus 7 is 3. Decimal point, 0 minus 0 is 0. So we get an answer of 0.3. Oh, I've done it backwards, haven't I? Sorry. They've said it's 0.3, so we want 1 minus 0.3. Sorry, I did it in reverse. So our answer is going to be 0.7. Always good to check your work. Okay, on to question 14. Y equals 6x minus 5. Work out the value of y when x equals 4. So y equals, well, when we got a number next to a letter, it means times. So we're going to have 6 times. And instead of x, we can put 4. Okay, so we're going to think of our order of our operations, or BIDMAS. We've got multiply and subtraction. Which comes first? So multiplication. So we do 6 times 4, or 4 times 6, so 6, 12, 18, 24. So do that bit first, and then we've still got the minus 5 at the end. Well, 24 minus 5, let's just count back from 24. So 23, 22, 21, 20, 19. There we go. Work out an estimate for the value of 92 times 1.63. You must show all your working. Okay, so estimate, that's the key thing here. Well, 92 is close or approximately equal to 100. So if we've got 100 times 1.63, we're going to make the number bigger. We've got 2 zeros, so we're just going to move the decimal point 1, 2 times, or twice. So we end up with an answer of 163. Now, there could be more than one right answer on this, depending on what rounding you're going to do. You could round the 92 to 100, and you could round the 1.63 to 2. So or even rounding it to 90 and round it to 2 if you want to do it to one significant figure for each one. Either way would be acceptable answers. And then given that 2.96 times 3.2 equals 9.472, find the value of 29.6 times 32. Well, let's look at the decimal point. Well, this has moved 1 here, so this is 10 times bigger. So that's times 10. And then from the 3.2 to the 32, that's moved once as well. So that's 10 times bigger. So if we know the answer here was 9.472, we said the 29.6 is 10 times bigger than 2.96. So move the decimal point once. And for the 32 is 10 times bigger than the 3.2. So we're going to move it again. So we end up with 947.2. Question 16. Savio leaves his home at 07:30 to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? Okay, so he's doing 50 miles and he thinks he's driving at an average speed of 40 miles per hour. So in the first hour, he'll drive 40 miles. In this what's left, basically. So let's do 50 minus 40, 0 minus 0 is 0, 5 minus 4 is 1. So he's going to drive for 1 hour and 10 miles out of 40. So we can use this, cancel the zeros, to say, well, basically it's going to be a quarter of an hour. So in total driving time is 1 1/4 hours, which we can write as 01:15 if we're writing it in a similar way to what we've got up here. So we start off at 07:30. I'm going to put the dots in, I find that easier to look at. We want to add on 01:15. 0 plus 5 is 5, 3 plus 1 is 4, 7 plus 1 is 8. So he would arrive at 08:45. In fact, Savio's average speed was greater than 40 miles per hour. How does this affect your answer to part A? So, if the speed is greater, the time taken will reduce. So you're driving faster, it'll take you less time to get there. So he will arrive earlier. Or we can put earlier than 08:45, just to be complete. They haven't said how much greater it is, so we can't work out an exact value. But it's only worth 1 mark, so giving some words to describe it is what they're expecting. Question 17. 72 people did a test. 20 of the 32 adults who did the test passed. 6 of the children who did the test failed. Use this information to complete the frequency tree. Right, 72 people did a test. So we can put 72 in here. Right, 20 of the 32 adults, so they're telling us 32 of them are adults. And it says 20 of those who did the test passed. So 20 of these passed. Right, well, if 20 passed, well, the failed ones must be 32 minus 20. 2 minus 0 is 2. 3 minus 2 is 1. So these two need to add up to this one here. So similarly, these two need to add up to this one here. So 72 minus 32, 2 minus 2 is 0, 7 minus 3 is 4. So we've got 40. Now there was another bit of information. 6 of the children who did the test failed. So the children are down here. 6 of them failed. So the ones that passed must be 40 minus 6. Well, let's just count back from 40. 39, 38, 37, 36, 35, 34. There we go. We've got part B down here. One of these people is picked at random. Find the probability that this person is an adult who failed the test. And that's worth 2 marks. Now it says one of these people. Well, we've got 72 people. So that's going to be the denominator. We want the ones, an adult who failed the test. So adult failed was 12. So it's going to be 12 out of 72. It hasn't said to write it in its simplest form. You could divide top and bottom by 12 and put it as a sixth if you want to, but it hasn't asked for that, so you'd get the full 2 marks with either of these. Question 18. Here is a list of ingredients for making 10 scones or scones. So ingredients: 75 grams of butter, 350 grams of self-raising flour, 40 grams of sugar, 150 millilitres of milk and 2 eggs. Mia wants to make 25 scones. Work out how much sugar she needs. So we're only interested in the sugar here. If this is for 10 scones, then for 1 scone, we'd want to divide that by 10, which would be 4 grams. We want 25, so we want 4 times 25. Okay, or we can do this 25 times 4. So 4 5s, we've got 5, 10, 15, 20. 0 carried the 2. 2 times 4 is 8, plus 2 is 10. So we've got 100 grams needed. Question 19, this is for 3 marks. Increase 240 by 20%. So we want to work out what 20% is and then add it on to 240. Nice way to do this is to think, well, 20% is 10% plus another 10%. And the reason we do that is because 10% of something is quite straightforward. 10% of 240, well, we just take a 0 off, because 10% is dividing by 10, so it's just going to be 24. So 20% of 240, well, it's going to be double that, or 2 24s. I'll do it as doubling. So 2 times 4 is 8, 2 times 2 is 4. Okay, so 20% is 48. We want to increase it by 20%. So we want to start with our 240 and then add on the 48. 0 plus 8 is 8. 4 plus 4 is 8. 2 plus nothing is 2. It's 288. Question 20. The diagram shows 3 identical rectangles, A, B and C. A, B, C. We're told that 5/8 of rectangle A is shaded. That's this bit here. 9/11 of rectangle C is shaded. Okay. Work out the fraction of rectangle B that is shaded. Okay, so for B we want to take off this bit, take off this bit. So with A, this is 5/8. So this top bit, if this is 5/8, well, we've got 6, 7, 8. So we've got 3/8 unshaded. It's the same as up here. And then if we look at rectangle C, 9/11 are shaded. So the unshaded bit must be 10, 11. So it must be 2/11. Okay. So if we want to find out this shaded bit in here, what we need to do is add these 2 bits together and then take them off of 1. Okay. So we'll do that step first. So we want 3/8 plus 2/11. And the best way to do that is ideally we'd want the lowest common multiple of these 2, but we're just going to multiply these together. So 11 times 8, 1 times 8 is 8, 1 times 8 is 8. And the reason I'm doing this is because I know that 8 goes into 88 and so does 11. So that can be our common denominator. We need both denominators to be the same so we can add them. And instead of writing them as 2 separate fractions, I can just write the numerators separately but have the denominator showing it's the same. Now, to get from the 8 to the 88, we multiplied it by 11. So we want to multiply the 3 by 11. Well, 11 times 3. 1 times 3 is 3. 1 times 3 is 3. So we're going to have 33. Now, for the 11th up to 88, we multiplied the 11 by 8. So we need to multiply the 2 by 8. And, well, 2 times 8 is 16. Okay, so 33 plus 16. Let's do that over here. 3 plus 6 is 9. 3 plus 1 is 4. So we've got 49 88ths. Now that is unshaded. Okay, so we've worked out the total of these two sections. So this bit in the middle is everything else. Well, if you think the whole thing would be like 88 88ths, that's how much we start off with. That if we want the shaded bit, we need to subtract the unshaded bit. So we're taking off 49 88ths. So the denominators are the same, so stay as 88. We want 88 minus 49. 8 minus 9 we can't do, so reduce that by 1 and make that 18 minus 9. So 18 minus 9 is 9. 7 minus 4 is 3. So we end up with 39 88ths. I can put that down here. Question 21. Here are the ages in years of 15 people. Show this information in a stem and leaf diagram. Right, so they've actually given us a stem and leaf diagram down here. What I'm going to do is I'm going to sketch one. I can still use my ruler for it. I'm going to sketch one to do as a rough working. And it's always good to sort them as well, so I'll do this as my practice one. Now if we look on here, we've got 1, 2, 3 lines going across. 1, 2, 3. Okay, so let's start writing the numbers on. Well, we start off in the teens, and the highest we go up to is the 40s. So I'll put a 1 here. So 19 would be 1, 9. 28 would be 2, 8. 29, we've already got 2 for the 10s, so we can just put a 9. 33, so 33. 27, again we're going to have in the 20s, so we can just put the 7. Another 27, 7, 37, 37, 25, 2 and a 5, 27 again, 2, 7, 37, 3 and 7, 17, so that's 1 and 7, 45, we haven't had any 40s yet, so 45, 47, so 47, 25, another 5 here, 26, 26. Right, so that's our unsorted stem and leaf diagram. We want this to be our sorted one. So we're going to have our 10, 20, 30, 40. Now we just want to sort these into numerical, like increasing order. So we'll have 7, then 9. With these, we've got 5's the smallest number, so we've got 5, 5. Then we've got 1, 6. Then we've got 1, 2, 3 7s. 7, 7, 7. And then 8 and 9. For the 3's, well, these are in increasing order already. 3, 7, 7. So are the 4's. Now for the key, we're just sort of showing how we've written this. And basically what we're saying is if you've got something like 1, line 7, well, that means 17. If because you can write this slightly differently, but I'm not going to confuse it by showing any other ways. I think this is the most straightforward way to do it. Question 22. The centimetre grid shows the plan and the front elevation of a cylinder. Okay, so remember, the plan is like the bird's eye view looking down on a cylinder. In fact, let's just show what do we mean by a cylinder. Well, it's something like this, like a can of Coke or a tin of beans or something. So we've got the plan, front elevation. Work out the volume of the cylinder. Give your answer in terms of pi. Well, the volume of a cylinder is equal to the area of the circle, so this bit on top here, multiplied by the height. Well, the area of the circle is going to be pi r squared, and the height we can just call that times h for now. Right, so it says give your answer in terms of pi, so we're not going to replace that, but we need to know what r is, and we need to know what h is. Well, r is the radius, so that's the distance from the centre of the circle, which is here, to the outside. So I'm going to do it here, so we've got 1, 2, 3, so that's going to be 3 centimetres. Because we're told it's a centimetre grid. Okay, so we've got r equals 3. We said we wanted h as well. Well, if this is the front elevation, this is going to be our h, which is 1, 2, 3, 4, 5. So h equals 5. We can put the units as well, centimetres. So pi r squared means we've got pi times r, which is 3. Squared means you times it by itself. And h, which is 5. So let's deal with just the number bit first. So 3 times 3, so 3, 6, 9. Well, let's just show that this is 9 times 5. And 9 fives would have 5, 10, 15, 20, 25, 30, 35, 40, 45. So it's going to be 45 pi. We don't need to do anything with the pi because they've just said give your answer in terms of pi. And they've given us the units as well, centimetre cubed. And that's for 3 marks. Question 23. Solve 7x minus 27 is less than 8. Right, okay, so we want to find this in terms of x. So you treat this as if that was an equal sign. We just want to have x equals. But because it's a less than, we're just going to end up with x is less than equal to something. So the first thing we want to do is to move the minus 27. So by moving it to the other side, it changes the sign and becomes a plus 27. So we're just left with the 7x here. And we've now got 8 plus 27. So 7 plus 8 is 15. 2 plus nothing, or plus a 1, gives us 35. So we've got 7x is less than 35. Now we want the x on its own, so we need to get rid of this 7. Well, at the moment it's 7 times x, so move it across, it's going to become divided by the 7. So we'll have x is less than, and 35 divided by 7. Well, let's do our 7 times table. 7, 14, 21, 28, 35. So that's 5. X is less than 5. Question 24, and this is for 2 marks. Write 124 as a product of its prime factors. So factors, they're the numbers that go into another number without any remainder. So we'll start with 124 up here. Well, it's an even number, so I know 2 goes into it. How many times? Well, let's use the bus stop method. 2 doesn't go into 1, but 2 into 12 goes 2, 4, 6, 8, 10, 12. That's 6 times. And 2 goes into 4 twice. So 62. So we've got 2 and 62. 2 is a prime number, so we can stop there. But 62, well, that's still an even number, so I know 2 goes into that again. Well, how many times? So let's see. 2 goes into 6, 2, 4, 6, 3 times. And 2 goes into 2 once. So 2 and 31. So what we're saying is 2 times 31 makes 62. 2 times 62 makes 124. Well, 2 is prime. What about 31? Well, 2 doesn't go into it. What about 3s? Well, no, because 3 tens would be 30. So you can try different ones, but hopefully you'll get to the point of seeing that 31 is a prime number. So we've got 3 prime factors. So we can put 124. It wants it as a product, so multiplying them together. So it's 2 times 2 times 31. If you want, you could write it 2 squared times 31. But either way is fine. Question 25. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans equals 3 to 7. So for every 3 cars they've got 7 vans. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity. 25% of the cars use diesel, and the rest of the cars use petrol. Work out the number of cars that use petrol. You must show all your working. Right, so we're interested in cars. So first of all, we're going to find out how many of these 160 are cars. So we need to start with our cars and vans. So I'm going to draw a quick little ratio table up here. And we've got cars, we've got vans, and we've got a total. And the ratio is 3 cars for every 7 vans. If that's all we had, well, 3 plus 7, or 7 plus 3, we'd have 7, 8, 9, 10. But we haven't got 10. We've actually got 160 in total. So how many lots of this row do we need for this row here? And the way we can do that is say, well, 160 divided by 10. Well, we can cancel the zeros. We just got 16 divided by 1, which is 16. So we want to multiply everything in this row by 16 to get the new row here. So we're going to 3 times 16 and vans times 16. We don't actually need to do the 7 times 16 because we're only interested in cars. So let's just focus on this bit here. So 3 times 16 or 16 times 3. 3 times 6, 6, 12, 18. And 1 times 3 is 3, plus 1 is 4. So we've got 48 cars. Right, that's our starting point. So what we can do is, let's do another table. This isn't a ratio table now. This is just a table to put our results in. So we're going to have electricity, diesel, petrol, and total. And we know we've got 48 for our total. 1/8 of the cars use electricity. So we want 48 divided by 8. Well, let's do our 8 times table. 8, 16, 24, 32, 40, 48. So that's 6. So 1/8 of 48 is 6. That's the number of cars that use electricity. 25% of the cars use diesel. Well, 25% is a quarter. quarter. So we want 1/4 of 48. So in other words, that's going to be 48 divided by 4. 4 into 4 goes once, 4 into 8 goes twice. So we've got 12 diesel cars. So the petrol cars must be whatever's left over. Well, electric plus diesel, 6 plus 12, we've got 2 plus 6 is 8, 1 plus nothing is 1. So this is 18. So the petrol cars must be the total minus the total of the, or this one here, the electric and diesel. 8 minus 8 is 0, 4 minus 1 is 3. So we must have 30 petrol cars. That's what we've been asked to work out. And we can put that in down here and see that we've got 5 marks for that question. So quite a few marks there, but you really need to split it up. So deal with the ratio first to find the number of cars, and then we work out the number of cars for each of the different types of energy. Question 26. Part A. Write 1.63 times 10 to the power minus 3 as an ordinary number. So 10 to the minus 3 is the same, because of the minus, it's the same as 1 over 10 to the power 3. Well, 10 to the power 3 is 10 times 10 times 10. 1, 2, 3 zeros, so that's 1,000. So if we think of that, basically, so what we're saying is this whole thing here is the same as 1 over 1,000. We're multiplying it by 1.63, but actually we divide 1.63 times 1 over 1,000 means 1.63 divided by 1,000, because we multiply by the 1, divide by the 1,000. So 1.63. Dividing it is going to make it smaller, so we're going to move the decimal point to the left. 3 zeros, so it's 1, 2, 3. Fill in the gaps with zeros, and we get 0.00163. I feel I might have overcomplicated that. You could probably just say it's minus 3, so we're going to move it 3 to the left. But I think hopefully this just helps to add a little bit of reasoning for why that works. Right, 438,000 in standard form. So for standard form, we need a number which is between 1 and 10. So we're going to put the decimal point in here. So we've got 4.38. Now, how do we get to this number? So we move the decimal point 1, 2, 3, 4, 5 times. So it's going to be 4.38 times 10 to the power 5. Part C. Work out 4 times 10 to the power 3 times 6 times 10 to the minus 5. Well, what I'm going to do, although we've got these in brackets, because they're on multiplication, we can ignore the brackets. So I'm actually going to deal with the 4 times 6 first of all. Well, 4 6s, 6, 12, 18, 24. So we've got 24 times 10 to the power 3 times 10 to the power minus 5. Now, hopefully you remember from your indices rules, when you've got two numbers that are multiplying together with different powers, you add the powers. So we've got 3 plus minus 5. So then for number line, we've got 3 on the number line, that's 0. We're adding minus 5, so that means we're actually taking away 5. Let's draw some lines on here. So it'll be 1, 2, 3, 4, 5. So it would take us here. That'll be minus 1. So it's going to take us to minus 2. So all of this can be written as 10 to the power minus 2. So we've got 24 times 10 to the minus 2. Now, we can keep the 24 as it is. And remember, if it's to a minus power, it's the same as 1 over to the positive power. Let's keep the 24. Keep the 1. 10 squared, well 10 times 10 is 100. So we've got 24, so it'd be 24 times 1 divided by 100. So we've got the 24. Dividing it, we're moving the decimal point to the left. 2 zeros, so it's 1, 2. We get an answer of 0.24. Okay. However, we've just written that down and realised that it says give your answer in standard form. Well, that's not standard form. Remember, standard form needs to have the first figure, like this, between 1 and 10. Well, 0.24 isn't between 1 and 10, but 2.4 is. So we're going to need it 2.4. But how are we getting from here to here? Well, we're moving that decimal point 1 to the left. So we're multiplying it by 10 to the minus 1. And we put that on here. Question 27. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. You must show all your working. So here's X here. So what we want to do really is, if we can work out the size of this angle and this angle, we can use that and the fact that the total number of degrees around a point are 360 degrees. So we can add those together, take them away from 360 and find out X. The only small bit we need to do is, how can we work out what each of these are? Well, there are some handy formulas, but they're very easy to forget as well. So what I like to do is to just work it out. You don't need to remember the formula. What we can do is we can split our shapes into triangles. It doesn't matter how you do it. Let's split it up like that. Okay, and I know that in each triangle, the total of the angles is 180 degrees. So that means the total degrees in this shape, our hexagon here, is going to be 1, 2, 3, 4 times 180. 4 times 0 is 0. 4 times 8, 8, 16, 24, 32. 4 times 1 is 1. Sorry, 4 times 1 is 4, plus 3 is 7. So 720 degrees in total. We've got 1, 2, 3, 4, 5, 6 corners. So 720 divided by 6. 6 goes into 7 once, remainder 1. 6 goes into 12, 6, 12, that's twice. 6 doesn't go into 0. So each of these angles, because it's a regular hexagon, so all of these are going to be the same, and they're all going to be 120 degrees, as just worked out here. We can do a similar thing with our pentagon. Split this into triangles. So this triangle is going to have 180 degrees, so is this, so is this. So in total we've got 3 lots of 180 degrees. 3 times 0 is 0. 3 times 8, 8, 16, 24. And 1 times 3 is 3, plus 2 is 5. So we've got 540 degrees in total. And we've got 1, 2, 3, 4, 5 corners. 5 into 5 goes once. 5 into 4 goes 0 times, but we carry over the 4. And 5 into 40, 5, 10, 15, 20, 25, 30, 35, 40. That's 8 times. So each of these angles, including this one here, is 108 degrees. So if we add these two together, 120 plus 108, we get 8, 2, 2, so 228 degrees. So X must be 360 degrees all the way round, minus these two added together. 0 minus 8 we can't do, so reduce that by 1. Make that 10. 10 minus 8 is 2. 5 minus 2 is 3. 3 minus 2 is 1. We've got 132 degrees for 3 marks. Question 28. Complete the table of values for y equals x squared minus 3x plus 1. So we can do it in any order. You might find it easy to do the positive numbers first, actually, rather than dealing with the negative. Let's start with the 2. So with this one, we're substituting the 2 in for the x. So we'd have 2 squared minus 3 times 2 plus 1. Well, 2 squared, or 2 times 2 is 4. So it's going to give us 4 minus 3 times 2 is 6 plus 1. So 4 minus 6, come back from 6, so it'll be 3, 2, 1, 0, minus 1, minus 2. Add on 1, take us back up to minus 1. Now let's do the same thing for the 3. So we're going to have that y equals 3 squared minus 3 times 3 plus 1. Well, hopefully you'll see that 3 squared is the same as 3 times 3. So they're going to cancel each other out, because we've got 3 squared is 9 minus 3 times 3, which is 9. All we're going to be left with is 1. Now if we do it for the 4 as well, we get that y equals 4 squared minus 3 times 4 plus 1. Well, 4 squared, 4 times 4, 4, 8, 12, 16, minus 12 plus 1. Well, let's do 16 minus 12. 6 minus 2 is 4, 1 minus 1 is 0. So we've got 4 plus 1, which is 5. Right, so now we need to work out this one as well with the minus 1. Now, 2 ways of doing it. We can do the y equals minus 1 squared minus 3 times minus 1 plus 1. And we are going to do this, but I'll show you an easier way of doing it as well. Minus 1 squared. So minus 1 squared means minus 1 times minus 1. So the minuses cancel each other out. So it's essentially just 1 times 1, which is 1. Now minus 3 times minus 1. Well, 3 times minus 1 would be minus 3. But because it's minus minus 3, it becomes a plus 3. And then we've still got the plus 1 on the end. So 1 plus 3 is 4, plus another 1 is 5. But hopefully you can see it would be very easy to get that mixed up and get the minuses in the wrong place and add when we should take away, or the other way around. The easier way to do it was to look at the values, and because it's a quadratic equation here, I know that the values are going to be symmetrical. We've got minus 1 and minus 1, 1 and 1, so I know that whatever value I've got here, this is going to be the same. So what I would actually do is work out both, but use this to check. But if you were pressed for time, you could work out 1. If you can see where the where it's symmetrical, you can then just put the other value in. Because it hasn't said calculate, it just said complete the table. So it's not cheating by copying it across. Now for part B, we've got on the grid, draw the graph of y equals x squared minus 3x plus 1, which is what we've done, for values of x from minus 1 to 4. So that's what we've just worked out. So at minus 1, we've got y is 5. So minus 1, 5. When x is 0, y is 1. So 0, 1. When x is 1, y is minus 1. and y is minus 1. When x is 2, y is minus 1 as well. So here. When x is 3, y is positive 1. And when x is 4, y is 5. X is 4, y is 5 up here. Now to draw the graph, we don't want to use a ruler because this is a curve. I'm going to sort of turn the paper to see how I can best join these lines together freehand. Now this bit at the bottom, it's going to be a bit of a curve, so I'm actually turning the paper so I can sort of draw a bit of a curve like that. That's going to come that way. I find it easy to draw the curve on top, so that's why I've got my paper completely upside down. But when I turn it around, hopefully you'll think, that looks quite tidy. Now, part C. Using your graph, find estimates for the solutions of the equation x squared minus 3x plus 1 equals y. So the solutions of the equation means what are the possible values of x that make our y value 0? Well, y0 is on this line here. So it's going to be here and here-ish. Basically where the curve is cutting through the x-axis. Now, it doesn't matter too much which one we go for. I think I've probably got my line a little bit out. But so what we want to do really is we want to read off the coordinates for here. So on this one, it's coming pretty much right in the middle. So this is looking like 0.5, halfway between 0 and 1. And the y coordinate is always going to be 0. Okay. In fact, we can just say the estimates are going to be, so this one's going to be x equals 0.5. And on this one here, well, the way I've drawn it, this is probably more like x equals 2.7. But really, I know that this is symmetrical, so I'd probably try and work out, well, which of my sides looks better, and so this should probably be a bit steeper. So I'd probably bring this line over a bit, say it's more like that, and we'll say x is 2.5 instead. So we can put x equals 0.5, x equals 2.5. They will allow you to be within a certain tolerance, okay, because it is just a freehand sketch here as well. Let's say, because I know that it should be symmetrical, I'm trying to have them sort of almost sort of opposite. So we'd know that halfway would be sort of 1.5 here. So this gap should be the same as that gap. But you don't need to worry about it too much. What you want to do is mark on here where your lines cross through the x-axis and take those values as a solution to this equation. Question 29. Here are two cubes, A and B. Cube A has a mass of 81 grams. Cube B has a mass of 128 grams. Work out the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers. Right, so density. You've got to remember what density is. Density is how heavy something is for each unit of volume. So it's mass divided by volume. Well, we've got the mass of each of them, so we need to work out the volume of each of them. And volume, well, it's for a cuboid, it's the length times the width times the height. For a cube, because those measurements are all the same, it's going to be 3 times 3 times 3. Well, 3 times 3, 3, 6, 9. And then 9 times 3, 9, 18, 27. So we've got 27 centimetres cubed. We do the same with this one. So it's going to be 4 times 4 times 4. 4 times 4, 4, 8, 12, 16. I won't do this in my head. We need to multiply that by 4 now. So 4 times 6, 6, 12, 18, 24. 1 times 4 is 4, plus 2 is 6. So we've got 64 centimetres cubed. So we want the density. Well, of cube A, we're going to need the mass, so we're going to need 81 divided by the volume, which was 27. Okay, so we can write that as 81 over 27. And then say, well, what common factors? Well, I can see that both of these are in the 9 times table. If you can't see that, then maybe you can try smaller numbers, maybe divide it by 3 first of all, and then see if you can simplify it further. But because I can see 9 goes into both, and I know 9, 18, 27, so 3 9s are 27, and for the top 9, 18, 27, 36, 45, 54, 63, 72, 81, that's 9 times. Well, 9 divided by 3 is just 3. So the density is 3 grams per centimetre cubed. Now what about for B? Well, for B, the density is going to be the volume. Sorry, not the volume, it's going to be the mass, which is 128. And divide it by 64. Or we can write it as a fraction, 128 divided by 64. They're both even, so you could keep dividing by 2, but actually I've spotted here that 128 is actually 2 lots of 64. So that's the same as 1/2. Let's say you can do it by dividing by 2 and keep going until you get there. You'll still get down to 1/2. So 1/2 is going to be, oh sorry, it's not 1/2, is it? 128 over 64, so it's 2 over 1, it's the other way around. So it's just going to be 2, and that's going to be grams per centimetre cube. So the ratio, the density of cube A to the density of cube B is going to be 3 to 2. So quite a complicated question with what looks like quite a straightforward answer. Definitely not an easy one. Question 30. Write down the value of sine 30. Right, so if you can remember what these are, and I'd encourage you to remember them or learn them, because generally they're going to be just for 1 mark, so you want to be able to just run them off straight away. If you can't, and you've got a bit of time left over, then what I'm going to do now is show you how you can work it out. And what you need to remember is that, well, these all of these trigonometrical functions are based on triangles. So we're going to draw we'll do a quick sketch of an equilateral triangle. Doesn't have to be exactly, but as long as we know it's supposed to be an equilateral triangle. So if it's equilateral, then I know that each of the corners are going to be 60 degrees. Now, what I'm going to do is say, well, let's imagine that each of these sides are 2 centimetres. We're trying to get an angle of 30 degrees, by the way. So what we can do is, if we cut the triangle down the middle, well, that's a right angle. So we've got 90 degrees, 60 degrees. So that must be our 30-degree angle up there. Also, we've split this line in half. So this bit here must be half of 2, which is 1 centimetre. So now I'm going to redraw half of my equilateral triangle. So we've got 30 degrees, we've got 1 centimetre, and we've got 2 centimetres. Now if we remember my formula, SOHCAHTOA, it's a sine, equals the opposite over the hypotenuse. And the opposite would be the opposite the angle, which is 1. The hypotenuse is the diagonal, the longer side, which is 2. So sine of 30 is just 1/2. Feels a lot of work for 1 mark, but I think it's quite nice to see this and for you to sort of understand, right, I can just learn these off by heart, but actually this is where they come from. And you can do something similar for working out what cos of the angle is as well. So actually let's just fill this in. So that would be sine of 30 is 1/2 to be complete. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I add more videos, and I look forward to seeing you again soon. Thank you.